Good day everyone. Welcome to this session in which I want to rehearse PowerServer and discuss the new features of version 2022 revision 2. PowerServer is today the fastest way to convert Power Builder apps into NTR apps and upgrade Power Builder developers into highly productive cloud application developers. The cloud architecture represents the most effective setup to expose data with performance over complex networks and in particular over the internet. And to this regards, PowerServer transforms Power Builder client server applications into installable cloud apps. A short disclaimer for upon elevate contributions by volunteers. And let's start with the agenda. So the new features of PowerServer 2022 revision 2. This is a non-major release. It's not 2023 or 2024 version. It is 2022 revision 2, but still it includes a number of new features. We'll see how PowerServer project has been refactored in Power Builder, in particular to simplify the deployment and the test in dev environment. Then changes that you will find in the C# solution that must be opened from snap-develop to deploy the remote servers, the latest database versions that are supported, a new build option called ultra-fast, which saves you lots of time when it comes to repeated and quick fixes and redeployments. Technical-wise, a very handy new feature for dynamic setup of API URL. I will demo it and show how easy it becomes to set up fault-tolerant API servers and have the front end to switch among them if any network issues. Then discontinuous and obsolete features, but I will also review a couple of strategic concepts in the major release, PowerServer 2022, namely why and how the installation of Cloud App Launcher and lots of technical concepts and suggestions when it comes to database connection. Power Builder apps are database-centric, and it's extremely important that in spite the change in the underlying software infrastructure when moving from client server to cloud, it's very important that you can still manage database transaction with the flexibility and the power you are used to in Power Builder client server. Few words about myself. I am Appian MVP. I'm of course a Power Builder lover and of course on top of all a PowerServer enthusiast since its very early days some 20 years ago. SoftP is an Appian partner for product sales in Italy and Spain, and it's a true privilege for me to have a solid collaboration with them. I've been leading lots of migration projects to all PowerServer web and mobile products, and now enjoying the new family of PowerServer targeting installable cloud apps. Recently, I've grown up experience with web frameworks, while my academic background is mostly related to big data technologies and machine learning. For those of you who have little or no experience with PowerServer, PowerServer extends the capabilities of Power Builder so that a PB app can be deployed to NTR architectures using only your PB skills for business logic and UI. It is today a PB target features that automatically converts client server into installable cloud native apps, in short, an ICA. In this picture, you see the ICA, the client app, that enables end user to access the existing Power Builder apps from Windows devices over the internet, and the app looks and works the same as before, supporting almost all Power Builder features. With a cloud-native architecture, end user no longer have direct access to the database, and all data windows and embedded SQLs execute on the .NET server behind the firewall. The backend logic is secured using token technologies, It can be deployed to remote cloud architecture like Azure or AWS, or microservices containers such as Docker, with underlying open source net framework supporting DevOps tools and a variety of authentication and authorization standards. This timeline at the bottom of the picture shows the milestone of the old PowerServer in white arrows. From its origin around 2003, then 2008, when the .NET IIS support was introduced in addition to J2A application server. In 2013, Appian Mobile was born, and so you could build native iOS and Android apps. And let me remind 2017, when Appian took over Power Builder from SAP, and Appian Web and App Mobile were rebranded into PowerServer Web and Mobile, as we know them today. Starting from version 2021, the new PowerServer generates cloud-native Windows apps instead of web or mobile. Then let me show you immediately what PowerServer produces in terms of installable cloud app directly from your Power Builder IDE. So let me switch to Power Builder 2022. This is the latest version, revision 2. And here I want to show you the sales demo Power Builder app deployed as a PowerServer app. So you can click on File, New, and select under project label the PowerServer icon, which will ask you to give a name and set up the database that the backend will connect to, and then a few options about the building with the list of libraries belonging to this project, and then deployment features. We'll go through them later in more details, but a lot of simplification are now available, especially if you want to run immediately the PowerServer app from your dev machine. To this extent, I will just open the PowerServer project that is available already in the application. It's called Sales Demo Cloud. Here you can see in the application option, you can specify the app name. That's the name that you give to your PowerServer Installable Cloud App. And then you can specify the list of files, assets belonging to your application, like INI file, text files, DLL, and a bunch of pictures that you need to display in your user interface. Then you have a few options in terms of security. For example, you can sign the installable cloud app, the executable that will be executed on the client machine. Database option, in this case, we're going to use Power Builder DB Demo version 2022 revision 2. Build, I will make it full, and then you also have a number of options in the advanced tab to specify versioning. And finally, the deploy options to specify whether you want to run the installable cloud app directly from the IDE, or maybe in production you want to deploy to a remote IIS server. And then the license code, which is the license in this case that comes with my Power Builder Cloud Pro version. All right, now I'm ready to trigger the build. From this icon in the PowerServer toolkit, it will take a few seconds. During this time, the PowerServer toolkit will split the front end from the back end. The back end is built by data objects and embedded SQL, and it will be published to the web server application server, Kestrel in this case. The front end instead will consist of an executable and all the PBDs, which will be very small and light in size to optimize the transfer. And finally, the executable is ready. So I can run now my project directly from the Power Builder IDE. And as you can see, the backend, the server API will start in console mode. So here I have my server running on localhost default port 5099, and also the front end will be started. And this is an application that you can know. This is an app that maybe you know very well. So it's the sales demo that consists of a number address, customer, products. Of course, these data don't come directly from the database through the native driver, but they'll come through HTTP request to the backend, and the backend will contact the database in order to provide the result set through HTTP response. So this is a cloud app, not a client server app. Okay, so back to our presentation now. And let me start with the first new feature in PowerServer 2022 revision 2. As you may have noticed already, the PowerServer deployment project has been refactored, and the settings for the development environment and the production environment have been simplified and separated so that developers can quickly get started with PowerServer now. Setting up a web server such as IIS for hosting the client app is no longer a must, and this because the client app can be directly hosted in the internal Kestrel server. And see here, the PowerServer API console started on localhost in development environment mode, default port number 5099, and in order to start the front end, you can simply click on the Run button in the Power Builder PowerServer Toolkit toolbar, or open your favorite web browser and type the name given to the Cloud app. So, by the way, in the advanced label, you can also create a package that includes not only the Cloud App Launcher, runtime files, and application files, but also the compiled web APIs. And this can directly deployed to the same sites or different application server or web server. Otherwise, you go to Snap Develop and publish the compiled web API to the Docker container using Dockerfile or Azure App Server or any remote server that you have. Just remember that when deployed to remote IIS, you need to install ASP.NET Core Hosting Bundle in order for the IIS Process Manager to automatically launch the PowerServer Web API. The PowerServer C# solution has the following new feature. First of all, here you can see the old structure of the C# solution in PowerServer 2022, whereas this screen here on the right shows the new structure in 2022 revision 2. And there is a new project called User Extensions that contains miscellaneous existing utilities such as logging, authentication, management API, etc. And as the project name suggests, you can also customize and enhance this project by adding additional code and functionalities. And this project, it's very important, will remain unchanged and unaffected when the solution is updated by a new full or incremental deployment. So here you can put your customization and they won't be overridden next time that you will perform an incremental or full deployment. There is a new setting called max storage procedure cache, which is added to the application JSON file. This setting specifies the maximum number of storage procedures for which the driver caches information. The driver retrieves information from the DB server about storage procedure parameters. The first time that the storage procedure is called and caches that information. The next time the procedure is called, the driver retrieves the information from the cache to improve performance instead of from the database. And you can turn off this caching by setting the value of max SP cache to 0. All right, up-to-date list of supported database in revision 2. IBM DB2 UDB11 is supported in PowerServer for the first time. Then you have Informix 14, Oracle 23C, PostgreSQL 14 and 15, SQL Server 22 or Azure SQL. And also PowerServer, likewise Power BI 2022 revision 2 supports strict encryption for SQL Server. In previous version of SQL Server, encryption could be turned off or not enabled, but to meet the standards of mandatory encryption while using the latest version of SQL Server, strict encryption is now available, and you can set it either from the Power Builder ID or in the server API cache settings. Here you have among the connections these options, security options, encrypt equal strict. Now, a new option called cursory ultra fast is apt to speed up the build process for especially for large PowerServer projects. This option can regenerate and redeploy only objects that have changed. Now, unlike incremental, this option will not generate objects that have inheritance or references with a changed object. Therefore, this option should be used after the project has been fully built and only independent objects have been changed or the change has no impact on the other objects. In order for the cursory ultra-fast build option to take effect, you will need, first of all, to enable the option in the PowerServer project, and also in the application object under the PowerServer tab, select this checkbox at every save, create 10 files required for cursory build. The option can save you lots of time because overall the PowerServer build is lower than the Power Builder build because it has a lot of work to do in addition. It needs to generate or update the PowerServer C# solution, obtain the database schema for the conversion, and then convert the data window objects to net data store models, and parses the embedded SQL statements and add them to the app models projects. But then also configures or updates the PowerServer Web API compilation environment, compiles the scripts and analyzes unsupported features, generates the PBD files, the application executable file, and other application files, and finally encrypt the compiled files, maybe sign the executable, and deploy them to the web server or create an installation package. That's why deployment in PowerServer takes more time than Power Builder build, and this new option, ultra fast build, is very handy. It can save you a lot of time, especially when you need to undergo a lot of um, quick fix in your project. Now let's talk about enhancements when it comes to calling the PowerServer API. You can specify the web API URL in the following way. Each client app deployed to the web server now contains an app run JSON file. It's a configuration file that tells the client app where to download the launcher and the runtime of Power Builder, and on top of all, where to connect with the web API. The launcher URL and the runtime URL can be a short address without including the site URL, or also, if you want, a complete URL address including the site URL. The web API must be a complete URL address. I call it a static API URL change because now you can simply modify this app run JSON configuration file on the server and restart it, and all the client will get the new web API URL. The old method until PowerServer 2022 was needs you to issue this command .NET customize deploy DLL with the option -URL on the remote web server to apply a change in the API URL. But it is now dismissed, so you cannot use it anymore because there is this new app run JSON file, which is way more handy. On the other hand, if you want to go for a dynamic approach, that's why I call it dynamic API URL change, the web API URL can be set via the Power Builder set PowerServer URL function at application runtime. And after that, you must manually create a session with this function begin session. They are both two methods of the application objects. So either you use the application object name or the get application system function. And remember, after the session is created, the URL cannot be changed anymore via set PowerServer URL until the session is ended. For begin session to take effect, you must select the dynamic session parameters option in the application properties PowerServer tab. So for example, if begin session returns -1 because any failure, network failure, that the API server is down, then you can switch to the backup server when the primary web API server is not working. So very handy and easy to implement this way an application level fault tolerance mechanism. And I'll show you later a short demo about that. Discontinued features and obsolete features. Discontinued features are features that have been completely removed from the product. Obsolete features are still available to use, but are no longer eligible for technical support and will no longer be enhanced. So just in case you're running, you are using PowerServer in older releases with .NET Core 3.1, you can still use it, but the new PowerServer 2022 revision 2 will use .NET 6.0 by default. So that is an obsolete feature. Discontinued the built-in OAuth server. So just in case you are using PowerServer with this auth template, there is a migration path to other technology such as JWT, for example. And then also, if you want to use FTP in your deployment process, the FTP deployment built in the Power Builder IDE has been removed, so please use a third-party FTP tool instead, for example, FileZilla. Okay, new demo. I want to show you the dynamic web API URL change. So I'll switch to my Power Builder machine. I'll stop the PowerServer sales demo app. And as discussed during the presentation, first of all, in the additional properties of the application object, PowerServer tab, flag the dynamic session parameters. And in the application object, I also uncomment these two lines that I added. First of all, I use the is PowerServer app global function that returns true if I'm running in PowerServer mode. So if I'm running Installable Cloud App, in this case, I will open this simple window, API server, where I have, in fact, a button that will trigger this user event. And this user event will call set PowerServer URL and begin session on the default web API URL, localhost 5099, in a try catch. If any errors, because for example I close the console, then I can switch to a second server. So I also have the same API running on this remote IS server over the internet, and again set PowerServer URL and begin session on the second URL. Let's see if it's working. So I have to do a full deployment. Let's wait for a few seconds, and then I'm ready to start again the PowerServer app. Almost done. And now run. So now I'm running in the default mode, so from the Power Builder IDE, which will open the localhost console for the server API, and also the front end, the user interface. I connect the API servers, I get the message, okay, I'm connected to localhost 5099, which is my localhost console. And of course, I can fetch the data as before. But now let's assume that I have I close this console. So let me start again the app. I can run it from the usual icon from the IDE, or simply I can type localhost 5099 sales demo cloud. So it's the same. So the app is started. But now I want to shut down my localhost console. Click Connect to API Service button. After a few seconds, you will get an error, so cannot connect to the local host. Trying a second API service, okay. And the remote server now will answer. So my front end now connects to this remote server API. The front end starts, and I will be able to get again the list of address, customers, product, and so on and so forth. So very simple to implement some kind of fault tolerance at application level. Now, let me take the opportunity to review some of the key new features of the main release, PowerServer 2022. Revision 2 is the latest version, uh, but lots of enhancements and improvements came out in the major release, and some of them are very, very important. That's why I want to spend a few words about the app launcher, the database connections that are crucial to any Power Builder applications. Power Builder offers a handful of scenarios when it comes to transaction objects, connection lifecycle. That's why I want to recap the key concepts such as transaction to cache, dynamic connection, long-running connection, and last, performance tuning by optimizing the multiple server calls in Power Builder script, which may slow down the corresponding PowerServer app. So this picture recaps the PowerServer components. From your development machine, you can deploy the PowerServer project to a remote server, and you will get two components. So the installable cloud app itself that is made of the front end, which in turn is split into the actual application, the cloud app launcher, and the Power Builder runtime. So these three guys will be downloaded, installed, and kept updated on the client PC. But also the API is running, and the ICA will authenticate and connect to the API for data processing. And it's the API that connects to the remote database and also the app on license server to check whether or not the license is valid, how many concurrent users you are running. So the Cloud App Launcher is a component that may have produced some installation headaches in prior PowerServer 2022, but version 2022 revision 2 has a streamlined implementation that translates into a better user experience. Simpler for developers, but also simpler for the end users. So why it is needed? It's needed because it's a loader. It's a helper app that downloads, installs, runs, and updates the installable cloud apps. And how it is installed, it can be opened via the web browser or installed separately. What type exists? There are two versions. The standard version requires no admin rights to install and use, whereas the public version requires admin right to install. So it's mostly for sysadmin that wants to push the Cloud App Launcher through, for example, domain policy, domain group policy. But after that, it can be used by all users without admin rights. And the launcher has been refactored in revision 2. So it is not backward compatible, but that means that multiple versions can coexist on the server and on the client. So if you are using already installable cloud app based on 2021 or 2022, then you can have both Cloud App Launcher on the client machines and on the servers. Now, let's talk about transaction to cache. Remember, Power Builder connection string is ignored by PowerServer. So in client server app, normally you connect to the database, specifying the connection string in transaction object SQLCA, and then you issue a connect using SQLCA. The transaction object stores and passes the database connection information. It's direct connection made from the client to the database. So client to server connection. And but below you see what is the PowerServer scenario. In installable cloud app, the database connection is made from PowerServer API to the database. So it's a server to server connection. The database connection information is stored in a cache in PowerServer. the transaction object is used only to find the cache. SQLCA is only used to find the cache that the server API will connect to, for example, local SA. It no longer passes the connection information from the client to the server, and therefore, for ICA to work, you will need to configure a cache and then map the transaction object to the cache. So this is called static mapping, static database connection, because the connection configuration, including connection cache settings and transaction to cache mapping, is created before the app is running. A second option is called dynamic cache. The goal is to choose the PowerServer caches at runtime. In this case, the transaction dbparm can include two parameters, which are only valid in PowerServer apps, not in Power BI client server apps. They are called cache group and cache names. So cache name is mandatory, cache group is optional. And dynamic database connection means, in fact, that the mapping between transaction object and cache name is created when the app is running. So a dynamic mapping can be created in the application script using the dbparm cache name and cache group. So this picture shows a possible scenario. The clients start the PowerServer ICA, passing, for example, the cache group as an argument in the query string. This is intercepted in PowerScript via the command parm argument of the application's open event, and then the dbparm is built in such a way that it contains the cache group and the cache name, so that the SQLCA transaction object can dynamically map the right database among all the caches defined in the PowerServer Web API JSON config file. In this file, in fact, you can create multiple caches which connect to the database with different privilege and use multiple groups to identify, for instance, different environments. Now, new feature is the long connection. So this is a new breakthrough features in PowerServer 2022 version. And let me give you a little background knowledge. First of all, in client-server apps like traditional Power Builder projects, is used long-running connection. A client connects with the database when the connect statement is executed, and the database connection is kept open and used by that client until the disconnect statement is executed. This means for a particular client, the database connection is always the same one. But in Installable Cloud App or web app, like in PowerServer projects, the database connections are short-lived because the database connection is made from PowerServer, not from the client. It is made by PowerServer Server API, and the database connection is cached in the pool when it is idle, and it is used by any client when necessary. This means, for example, for a particular client, the database connection may not be always the same one. It may use any database connection cached in the pool. For example, first connection A and then connection B. And for a particular database connection in the pool, it may be used by different clients. For example, first client X and then the same connection by the next client Y. So this different behavior may lead to pitfalls when it comes to PowerServer and in general cloud apps. In the traditional client-server application, for example, temporary tables will not be destroyed until a disconnect statement is executed. So after this temporary table is created, you can perform operations with this table at any moment you like during the application lifecycle. And same if you use context variables. You create them after they connect and they are removed at disconnect. But in the ICA, you cannot get the expected results because the temporary table is only valid in the current database connection, which is short-lived connection. If the temp table is created in a connection A and operations in connection B try to access this very same temp table, then an error occurs, such as table not found, or the temp table created in connection A is destroyed when connection A is returned to the tool. And then the operations with this temp table will fail even though connection A is selected again from the pool. And same is for context variables. When connection is released to the pool, they are lost. So with this in mind, to eliminate this difference, which depends not on by PowerServer but by the underlying three-tier architecture and stateless communication, from PowerServer 2022, you can set the long connection database parameter so that the installable cloud app can support the long-running connection and persistently use the same database connection for a particular client. If you set this option to 1, long connection equal 1, an ICA gets the same long-running connection as the PowerBuilder native client-server app. For instance, a temp table will stay active all the time and the same temp table will be used during the whole user session. It's recommended to increase the transaction timeout value, which is under 20 seconds by default, to have the same interval as the session timeout value, which is an hour, 3600 seconds by default. And this is to prevent transaction timeout during the session. Because if the transaction times out, then a new database connection will be created, which means the temp table is not the same one. Keep in mind this can introduce server overhead because connections are stateful, they are not released, and the more clients you get at the same time, the more connections are open. A best practice, I would say, is therefore to have two transaction objects in PowerBuilder. SQLCA, for example, that uses the pool, and SQLCB that uses the long connection parameter, and enable long-running connections just where and only you need it. Performance tuning, unlike the previous installable web app from the past PowerServer version, with the installable cloud app, there is no issue anymore with JavaScript conversion because the client app is Windows native, running the front end on PowerBuilder runtime as much as in a standard client-server app. So the focus is only on tuning excessive server calls because the network-intensive scripts highlight weakness of poor network connection, especially if deployment is done over the internet, which is great because it is a new setup you can use today from home, from remote, but internet latency may represent an issue for your application, especially if it is only written with client server in mind, with scripts performing a lot of server calls. So in PowerBuilder, for example, you have embedded SQL, select, insert, delete. You can invoke storage procedure. You can use data window, data store functions like retrieve, update, reselect row, or events like data window events, SQL preview, retrieve row. They all may lead to network chatter and low response of your original PowerBuilder scripts when converted to PowerServer, when converted to a three-tier apps because the network latency, uh, especially if the network is complex, especially over the internet. How to fix it? With separation of concerns. Namely, replace cursor with SQL in data window if possible, or eliminate recursive embedded SQL. eliminate data window computed fields, calling user function with embedded SQL, partition transaction, and using database storage procedure, for example. That's an old way to move business logic to database, but still very efficient. Or move the business logic to server-side REST API by means of rewriting the logic in C# and deploy it as a REST API that you can call from your PowerServer backend. But this, of course, requires some learning that goes beyond the automatism of PowerServer. Or, and this is where I want to take your attention, use the new PowerServer label object, which does nothing in client-server project, so you can keep the very same base code, but merges independent server calls when used in PowerServer projects. Independent request means the execution of one request doesn't rely on the execution results of another one in the same merged request, or one request doesn't use the return value of another request in the same merged request. Let me show you a couple of examples to make that clear. So script here encloses between the start merge and the end merge functions of the PowerServer label objects a number of server calls like data store retrieve, data window retrieve, and embedded SQL, and then execute immediate this SQL. Execute immediate effort SQL. So 4 server calls. That is, normally, rather than 4 round trips, client to middle tier to database with potentially high latency in wide area networks or cloud infrastructures, using the start merge and end merge, there is only one request that goes to the server side, as well as one HTTP reply back to the client. So that can speed up performance of your application by 4. Second script to the right shows the stop mode parameters that you can use with start merge. This is 0 by default, but if you specify 1, like in this example, the request will return if any error occurs in the merged request, with possibility of testing the results array and see if any SQL code reporting a failure. Again, the merge labels should only be used to merge independent requests. So independent request means the execution of one request doesn't rely on the execution of other requests in the same merged block. All right, time for conclusions. PowerServer 2022 is an excellent product, especially since the introduction of Installable Cloud App architecture for migrating potentially very large legacy PB app to the cloud. The Installable Cloud App Launcher is the component that downloads and installs applications automatically from a web server and keep them fresh and updated. The developers can just push a new change, all the clients will be automatically updated thanks to the Cloud App Launcher. Power Builder syntax support is about 100% thanks to the native desktop client technology, which is great because you don't get bogged down with unsupported feature. Conversion effort takes as little as a few days. You may need a few more days for subsequent performance tuning, but that is very predictable. PowerServer framework has an open REST API, as an open REST JSON architecture, and the database is still the core of your application, with high focus on connection types, transaction management, and server call optimizations. All right, so Q&A time. Thank you very much for your attention.